How's it going, guys? So today, once again, we're going to talk about some factoring, some math. Now, if you haven't seen my first video on factoring, if you don't know how to factor trinomials in general, you might want to watch that one first, okay? It'll help out with this. You maybe get a couple practice problems on that before you come into this because this is a little bit more complicated. The steps are about the same. We just add a step before and a step after, but these are for a shortcut, okay? Now, I can show you the long method, and I will. We'll start with the long method. We'll start with how you're supposed to do it properly. But then I'll give you a little shortcut that makes it a lot easier and a lot simpler to actually solve this problem. But we're going to start with this fact with a leading coefficient not equal to 1. So a is not equal to 1. In this case, it's going to be a 2. Now we can't factor this like we factor things normally. Main reason because of this 2. Now normally we'd look at this and say, okay, we got to figure out what multiplies to this negative 15. But this 2 here is going to make things a little more complicated. So what we have to do is the first step is to multiply my a and my c, my first and my last term together. I had to multiply those together. So I look and I say, okay, I multiply these together. That gives me a negative 30x squared. Now, what I have to do is try to figure out what multiplies to a negative 30x squared, but adds to a 7x, or find the factors of a negative 30x squared. So I look at here and I say, all right, it's going to be 1 times 30 2 times 15, 3 times 10, or 5 times 6. Now, because this is a negative, just like we chose before, the two numbers I choose have to subtract, okay? They have to subtract to this middle term, all right? So, and the bigger number always takes a sign. So I look here, I say 30 minus 1 is 29. Doesn't work. 15 minus 2, 13. Doesn't work. 10 minus 3, 7. 7's what we got. So the way you're supposed to solve this, the way that mathematically makes sense, is something like this. We write a 2x squared. We just rewrite this the same. And we're going to break this apart into these two. So it's going to be a plus 10x, and then a minus 3x minus 15. Okay. So what we did is we took this apart. These two are actually just that 7. I just broke those apart into two separate things. Now we're going to do what's called factor by grouping. Okay. Now what this does is it's kind of like the distributive property, but it undoes that distributive property. So I look here and I say, all right, is there a common factor between 2x squared and 10x? Now, if there is, I have to take that out from both of them. In this case, it's going to be 2x. And when I factor that off, I get 2x squared divided by 2x is just x. And 10x divided by 2x is just 5. Okay. Now I look here and group these two together now. And say, is there a common factor between negative 3x and a negative 15? Well, there's a negative 3. And that gives me, when I divide this negative 3x by negative 3, I get an x here. When I divide a negative 15 by a negative 3, you can use your calculators if you need to, it's going to give me another positive 5. Now, what I notice here is these two things are the exact same thing. That's what we need. If we did this properly, if we can factor by grouping, these two have to be the same thing. And I look and I say I have 2x outside here and a negative 3 outside here. I'm going to put these guys together and have a 2x minus 3. And then just bring down an x plus 5. And that's how you factor by grouping, and that's the proper way to factor something off when you have a leading coefficient. But that's not the fastest way. The fastest way is to look at these the exact same as you would a normal problem. Okay. So imagine this was a 1. We would see what multiplies to the 15 and adds to the 7x. So what we're going to do now is, this is the shortcut right here. We're going to do it right here. All right? Same problem. Same exact problem. I'll do it in green. Okay? So we multiplied them. We got a negative 30x squared. Same in both ways. Determine the signs. Now, the difference here is I have a leading coefficient of a 2x squared. So instead of writing x in the first spots, I'm going to write 2x in both those first spots. So then I can figure out my signs. All right? Actually, sorry, I need to find the factors of c, which we already did. and choose the right factors, which we already know. And if this is positive, then we have to add to that number. If it's negative, they subtract. And this is definitely negative because it's a negative 15. All right. So these two numbers have to subtract to the bigger number, or subtract to 7. So 10 minus 3, positive 10, negative 3. And the last step here is to divide the common factor between these, if there is one. Now 2x minus 3, there is no common factor. 2, 3, nothing. So I leave it the same. 2x plus 10, those I can both divide by 2. So I can divide off that common factor. We don't factor it, we divide it. So we look at this and say, all right, I have 2x minus 3. I divide 2x by 2, I just get an x. I divide 10 by 2, I just get 5, which is the same thing that we had right here. Now I know that's a lot. I know it looks really daunting, really difficult. So I'm going to give you a couple more practice problems real quick, all right? So more examples. I'll do the shortcut method. So what we're going to do is say we have 3x squared minus 2x minus 1. Once again, we have a leading coefficient here. So what we have to do anytime we have a leading coefficient we're supposed to factor is multiply these guys together. Now that that's done, let's determine our signs. Because this is negative, we're going to have a positive and a negative in there. They have to be different signs. And 3x goes in both spots because we have a 3x there, not an x. All right. Now, we have to figure what multiplies the 3. That's really simple. 1 times 3. That's the only thing. So we don't really have to figure out if it adds or subtracts because there's only one factor here. If we look at it and say, all right, 1 times 3, which goes where? That's the thing. Well, the bigger number always takes the sign of whatever b is. So in this case, my 3 is going to be negative, my 1 is going to be positive. And then the last step is to divide a common factor between the two terms. All right. Is there a common factor here? 3x and 1? No. So I leave that the same. Is there a common factor here between 3x and negative 3? 3. So I can divide 3 into each of these. And when I do that, what I get is x minus 1. That's it for that problem. It's a lot shorter than it looks. All right, so we're going to go over one more then. Well, this is going to be a little bit more difficult. So we have 6x squared plus 19x plus 10. All right, now if I had a common factor here, if this was even, I could try to factor that off first. In this case, we can't. So what we have to do is always multiply my a and my c. So when I multiply these guys together, what I end up with is 60x squared. Okay, that's fine. Now what we have to do is we have to figure out all the, determine the signs, and then figure out the factors. What goes in the first spots every time? 6x. Okay. Multiplies to a positive and adds to a positive. My signs have to be both positive. And then we have to find the factors of 60. Okay. So if I look at this, I figure what multiplies to 60? I can say 1 times 60. There's a ton of them. 2 times 30. 3 times 20. 4 times 15. 5 times 12. 6 times 10. And that's it. Okay. Now look here. And I say, all right, if this is positive, my c is positive. This last thing we have, this new c here is positive. We have to figure out what adds to 19 then. So these add to 61. These add to 32. These add to 23. These add to 19. So those are what we need to go with. Now in this case, it doesn't matter what I put where. 4 and 15, they're both positive. So I could put either one anywhere. So divide common factors between the terms if we have them. I look at this term first. Say, is there a common factor? Yes, there is. I can divide both these by 2. So I'm going to divide both those by 2. And I'm going to get 3x plus 2. Okay, I look at this now. And I say, is there a common factor between those? If there's not, I write it down. But if there is, I got to divide it. All right. I look here, 6x and 15. Okay. 3 goes into both those. So I divide both those by 3. 6x divided by 3 is 2x. And 5 divided by 3 is, 15 divided, I gave the answer away, sorry. 15 divided by 3 is 5. Now that would be my answer. If you want to check it, you can multiply this back out. And then combine your like terms. But what you're going to get is this is definitely your answer. Now these may seem a little more complicated, they seem a little more complex. The more you practice with just factoring regular trinomials, the easier these become too. Okay, so just practice those, get a strong grasp of that before you start really delving into this. But I need you guys to know this too, so if you have any questions, feel free to give me a call. You guys know how to get a hold of me. Adios.